All right, so let's go over these two problems. So here we have two triangles, but one is inside the other. Okay, so they tell you the similarity statement, so you don't have to guess the triangles. They tell you triangle XYZ, so X, Y, Z, that's the big triangle, so you can even label that. That's the big triangle, is similar, that's what that little squiggly line means, similar to triangle RYS. So that's RYS. So that's the small triangle. So now we know X matches with R because they're both first. So X and R, those angles are congruent. Y and Y are congruent to each other. And then Z and S are corresponding angles, so they're congruent to each other. So we can write that down. We can say angle X is congruent to angle R. Angle Y is congruent to angle Y because they're part of both triangles. And then angle Z is congruent to angle S. If you notice, I always put the big triangle angles first, right? I always put the big triangle first and then the small second. You always stay consistent. If you're going to say the big first, make sure you say the small second on every single one. If you want to say the small first, that's okay, but just make sure you say the small first for all your statements. Remember, order matters, so big to small or small to big. It's your choice, but stay consistent. So now let's look at the sides. Which sides are corresponding? So we don't say they're congruent to each other, right? Because sides are not congruent. They are similar, so that means they're proportional. That means you need to make ratios. So I'm going to do small to big again. So I'm going to do small over big. And so let's pick a side on the small triangle. So let's pick RY, right? RY. And that's going to make a ratio with the big triangle that corresponds to RY, which is XY. Okay. And that ratio is going to equal, right? That's what a proportion means. It means all the ratios are equal. All the side ratios are equal. So let's pick another small side. Let's pick YS. Okay. Now YS corresponds to what? On the big triangle corresponds to YZ. So I make a ratio of those two. And that ratio equals the third side. So let's start with the small one. We'll do RS. RS is the side on the small one. And what does that correspond to? Well, R corresponds with X. S corresponds with Z. So X, Z. So those angles are congruent and those sides are proportional, meaning we have to make ratios that are equal to each other with the small side on the top and the corresponding big side on the bottom. Ry over xy, that ratio would be the same as ys over yz, and that ratio would be the same as rs over xz. Okay, let's try one more, and now we're out of triangles. We have a quadrilateral here. So we have JKLM. So J, I'm going to put one arc. K, I'm going to put two arcs on an angle. L, I'm going to put three arcs. And M, I'm going to put four arcs. Now I'm going to put the corresponding angles so we know what matches. So QRSP, so Q is first, that's 1. R is next, that's 2. S is third, I'm going to put 3. And P is the last one, I'm going to put 4. And now you can visually see which angles match with which angles, and we can fill that out. Angle J is congruent to angle Q. Angle K is congruent to angle R. Angle L is congruent to angle S. And angle M is congruent to angle P. Okay, so now let's look at the sides. Which sides are corresponding? Again, let's go backwards. I'm going to go from big now on the top to small, just to show you that we don't always have to put small in the numerator. We can put the big one in the numerator. So let's pick a big side. And you can tell from here, maybe you can't, that this is the big quadrilateral, and then this one is the small quadrilateral. So I'm going to pick JK. So JK is a side. Now what is the matching side to JK on the small quadrilateral? Well, JK goes to QR. Matches with QR. So I make a ratio of those two. And that ratio equals, let's do KL on the big quadrilateral. And that matches with RS. See that? KL and RS. And now let's go to the next side. Let's do LM. LM, and that corresponds on the small triangle to SP. SP. Okay. And then the last side that we didn't do, MJ. Right? MJ will correspond to PQ. PQ. Okay. And don't forget, if you have any questions, you can always rewind this video and check what I did. You can play it in slow motion. I think there's a speed function down there where you can slow me down. Or you can speed me up if you think I'm going too slow. You can pause me, right, which you couldn't do in class. You can't pause me in class. You can pause me now, like, hey, shut up, Pacheco, and just pause me. Or you can send me questions on Remind, like, hey, mister, you explained this on the video this way. I don't know what you were talking about. Can you show me this is what I did, and I'll help you out. So just don't forget, you can always send me questions on Remind. Okay. So let's look at the next part where we have to find side lengths. Okay. So finding side lengths. And we're going to have to use, if you can't read this, I know it looks, if you can't read that, it says using proportions, right? So we're going to have to set up proportions. And if you remember, a proportion is just two ratios equal to each other. That's it, right? So I know over here we set up how many? For a quadrilateral, we had 4 proportions equal to each other. For a triangle, we had 3 proportions equal to each other. But when we come down here, we just need 2. We just need 2. Okay, so let's look at number 4. If the figures below are similar, okay, so they tell us right away, these figures are similar. So that we know right away they're similar, so that means the angles are congruent and the sides are proportional. Okay, if they are similar with a scale factor of 2 to 3, remember this is another way to write a ratio with that little colon, but 2 to 3 just means 2 over 3. And if you notice, which one's the smaller number, the 2 or the 3? The 2 is the smaller number, so that means we have small polygon over big polygon. Okay, it's really easy to see. Just look at the numbers. So that's how we're writing our ratios, small over big. Now let's find the value of x. So we know the scale factor is 2 to 3, so that means the sides have to match 2 to 3. So let's look at the polygons. Look at the picture. Which one of these is the small polygon? This one or this one? If you said the one on the left, you're correct. The smaller one is the one that says 42. So I'm going to put 42. Oops. I'm going to put 42 in the numerator because remember, we have small over big, small over large. So I put 42. And what's the corresponding side on the big, well, it looks like a parallelogram. On the big quadrilateral? X. Okay, so that's our scale factor, 2 over 3. Then we have 42 over x is our corresponding sides, and it has to be 2 over 3 because that is our scale factor. That means all the sides have that ratio. So do you remember how to solve a proportion or 2 fractions equal to each other? Right? We talked about this before. Cross products. Right? Some of you remembered it as the butterfly back in 7th grade. This is where you multiply across, and the cross products of a proportion are equal. So that means 2 times x equals 3 times 42. And so that means 2 times x equals 126. And so if we divide both sides by 2, we're going to get x equals 63. And so that means this side is 63, meaning the small side, 42, to the big side 63 is a 2 to 3 ratio, which is our scale factor, which is what they gave us. Okay. So I want you to try 5, 6, and 7, and then I'll make one more, or actually, just pause this video right here, try 5, 6, and 7, and then unpause it, or try 5, unpause it, and then try 6, and I will do the 5, 6, and 7 right now. Just pause this video to try 5, 6, and 7. Okay, I trusted that you paused it. If you didn't, it's okay. I'm going to go over this. So again, we have a scale factor. We have two figures that are similar, so they're telling you they're similar, and it has a scale factor of 6 to 5. So if you look at this, 6 to 5, that means 6 over 5. That means we have big to small. So we're starting with the big on the top on the numerator, and then the small on the bottom, the denominator. So I have a 6 to 5 ratio. Remember, that's big on top, small on the bottom. And so which one of these triangles looks like the small one? That's the small one to the right. And this one on the left is your big one. And so if x and 28 are corresponding sides, which I believe they are, we're going to put x on the top because that's on the big triangle, and 28 on the bottom because that's on the small triangle. And so that ratio of big to small of x to 28 has to equal the scale factor, which they told us was 6 to 5. So now we cross multiply, right? 5 times x has to equal 6 times 28. And what's 6 times 28? 28 is 6, that's 48. 6 times 2 is 12, plus 4 is 16. So 168 equals 5x. So if I divide both sides by 5, I get x equals, what is that? 35 and 3/5, so 35.6. Okay, so that means this side is 35.6, which means 28 to 35.6 is the same thing as 6/5. Okay. Now, if you haven't done 6, go ahead and pause it now, and then unpause it, and I'll go over 6. All right, hopefully you paused it. If not, it's okay. It's up to you. So now we're looking at A, B, C. Now they're giving us some actual letters, so we have to know which ones correspond to what. They are not giving us the scale factor, but they are giving us two lengths on each triangle, so we have to know what corresponds to what. So if we look here, A, B, C, so A, B, C is similar to D, E, F. So I'm doing what I did on the previous page. I'm seeing what sides are corresponding. So I'm doing that by showing which angles are congruent. We're not doing angles here, but I'm just doing that so I know what matches what. So if I look here, I have AB. AB is X, right? So what corresponds with AB? Right? So if we look here, it's DE, isn't it? So I'm going to put, this one's the large one, this was the small one, so I'm going to choose to put large over small. And so AB over DE, because those are the corresponding sides, should equal, let's look at the other side, we have BC, right? BC, and what does that correspond to? EF. Okay, so if I look here, this is a proportion I made. AB is to DE, that's how we say that. AB is a ratio to DE as BC is a ratio to EF, right? BC over EF, so these two should be equal. So now let's fill in the blanks. AB is, let's see if I can move this. Oops, nope. So if I can move this a little bit, there we go. So now AB, we know AB is X, DE is 25, BC is 28, and EF is 20. Okay, so I'm just using this proportion I set up like we did before, And now once I have the proportion set up, I can replace it with the actual values, and now I solve for x by cross multiplication. X times 20 equals 25 times 28. So 20x equals, let's get my trusty calculator, 25 times 28 equals 700. And if I divide both sides by 20, x equals 35. So that means this side is 35 units long. Okay, so how did we do this again? We used the similarity statement to figure out the corresponding sides and the corresponding angles. And so then I looked at the two sides and I made my proportion, my side proportions with AB and DE are matching, large over small. BC and EF are matching, again, large over small. And then I replace the values of each one of those. And then I solve for x. Okay. If you are confused, please go back and look at this again slower, pause it more, or send me a question on Remind so I can clarify any confusion you have, please. Okay, so now number 7, if you haven't done number 7, go ahead and pause it now. Try number 7 and then come back. All right, hopefully you paused it. If not, it's okay. So again, just like the previous problem, we have a similarity statement. PQRS is similar to WXYZ. So PQRS is similar to WXYZ. And so now if you look here, look at the sides that have lengths. Don't look at WX, there's nothing there. Don't look at YX, there's nothing there. Don't look at QR, nothing there. Don't look at QP, nothing there. We want to look at the sides that have actual lengths. So I'm going to go from, let's go from small to big now. This one's the small one. This one's the big polygon. So I'm going to go from small to big. So I'm going to go from ZW. Now what matches ZW on the big one? That's the one with 4 to the one with 1. So the one with 4 to the one with 1. So that's SP. Okay. And that should equal ZY, right, which is 4 to 3, which is SR. Again, I want small on the top, big polygon on the bottom. Okay, so there we go. ZW and SP form a ratio, right? Small to big. And then ZY to SR are the corresponding sides, small to big. So let's put what we know. Do we know ZW? Yes, that's 40. Do we know SP? Yes, that's 75. And that should equal, what's ZY? ZY is 32. And then what's SR? That's the X, that's what we're looking for. So we replace it, and now we solve. But you could simplify this fraction before we move on if you want to make your numbers a little nicer. But if you have a calculator, you can just do like we did the last problem. But let's simplify that. What can we simplify 40 over 75 by? Can't we divide that by 5? Right? So if we divide this by 5 and the denominator by 5, we would get 8 over 15, right? Equals 32 over x. So the number's a little nicer, so we can just solve it that way. So now we can cross multiply, cross products. 8x equals 32 times 15. Still something you probably don't know on the top of your head, but it's a little easier than 75 times 32. So 32 times 15 is 480 equals 8x. And you divide both sides by 8, x equals 60. Okay, so this side is 60 units long. All right, so that's the last of the packet. If you have any questions at all, go back in this video or the last video, slow it down, pause it, ask, maybe there's somebody at home that has taken this before, ask them to see if maybe I wasn't clear about something. But You can always send me a question on Remind. Don't forget. If any of this confuses you, please send me a question on Remind. I hope this helped, guys. So I will see you next week with next week's packet.